In the previous unit, Exponential Functions, Josh and Arobindo explored the growth of a magical beanstalk whose height tripled each day. They began by exploring the relationship between the time that had passed and the height of a beanstalk. They were able to create an exponentially scaled number line to model its growth. They were also able to create the following exponential equation to represent its growth: y equals 1 times 3 to the x. If you haven't watched that unit, you might want to watch that one before this one. In this unit, Josh and Arobindo will use their exponentially scaled number line to reason about exponential expressions, logarithms, and logarithmic expressions. In this first lesson, they will write two equivalent exponential expressions that represent the growth of the beanstalk over 2 consecutive time periods. This will result in an equation that is always true for any 2 consecutive time periods. They will begin by finding 2 equivalent expressions for the height of their beanstalk 5 days after day 2 and create a number line to represent these expressions.
Create a number line and explain the meaning of these 2 expressions on your number line.
So we have on day 2, the height, as you remember, was 9 centimeters. And you can always check that because you're starting on 1 centimeter. So the equation would be 1 times the growth factor, which is 3, and to the power of how many days have passed, which is 2. So you get 9 centimeters. So we did remember right. And
this thing, the 1 comes from the starting height. And then the 3 comes from the
growth factor?
Yeah, the growth factor. And you're multiplying by 3 every hump. So like you multiply, so it's 3 groups of 3 groups of 1.
Very nice.
And you get 9.
Okay, and now 5 days after 2 is, that's 5. So now we have times 3 and just keep on going. Well, why did I make them so big? I don't really care though. Okay, and we have done times 3 5 times, so that's 3 to the 5th. And we're timing that by 9 because we started at 9.
Arobindo is suggesting that the height of the beanstalk will be 9 centimeters on day 2 and will increase by a factor of 3 5 times, or 3 to the 5th, over 5 days. He proposes that the height of the beanstalk will be 9 times 3 to the 5th on day 7, which is 5 days past day 2. Continue watching as Josh proposes a different expression for the height of the beanstalk.
You can like start from like here and you can just like multiply by 3 7 times.
Yeah.
So what would that expression be? 3 to the 7th.
That would be 2 plus 5. 1 times 2.5 to the I forgot. Wait, I did it wrong actually.
Oh, you're showing where everything is coming from. Nice way to explain
3 and then 2 plus 5.
Mhm.
And then the 2 and this is like the days, and it equals 7, and the 2 comes from this, and the 5 comes from
the plus 5.
this, like this thing.
There. And then
then the 3 is the growth factor, and the 1 is the starting height. I finally did my T.
Yeah, and you basically just simplify it as Josh said, and you just get 3 to the 7th.
And could we see 3 to the 7th directly in the picture?
Yeah, because you could 1, 2, 3, 4, 5, 6, 7 groups of 3.
Okay.
In this episode, Josh and Arobindo were tasked with creating 2 equivalent expressions for the height of the beanstalk 5 days beyond day 2 and representing them on a number line. Arobindo found that the height of the beanstalk on day 2 was 9 centimeters, and the beanstalk would increase in height by 3 to the 5th centimeters over 5 days. So the height 5 days past day 2, or on day 7, would be 9 times 3 to the 5th. Alternatively, Josh noticed that the beanstalk's height tripled twice over the first 2 days and then 5 more times over the next 5 days. This means the height of the beanstalk tripled 2 plus 5, or 7 times over the total 7 days. He represented this repeated tripling in the expression 1 times 3 to the 2 plus 5. In the next episode, Josh and Arobindo will create similar expressions for the height of their beanstalk 18 days after day 2.